Good morning, everyone. I am MADIHA MUNAWAR from Stanley College of Engineering and Technology, 8th SEM student, Department of Computer Science and Engineering. Today, I am going to present my major project titled Bitcoin Price Prediction using Hybrid Machine Learning and Deep Learning Models on Time Series Data. This work focuses on improving prediction accuracy in highly volatile cryptocurrency markets using a hybrid modeling framework. So this is the table of contents. This is basically the outline of my presentation. We'll start with the abstract, then followed by the introduction, then the literature survey, then the proposed methodology, at last implementation, result analysis, which will be concluded by conclusion. Here's the abstract. This project focuses on Bitcoin price prediction using a hybrid machine learning and deep learning approach. So, as we know, Bitcoins is a decentralized cryptocurrency and are highly volatile and non-linear. So, making prediction is difficult. And we are using a multi-layer data set with OHLC values and technical indicators and applying pre-processing and feature engineering. Multiple ML, DL, and hybrid models are tested against the basic model ARIMA. So the proposed Bialistium model achieved the best performance with 98.96 R square, 3.64% MAE, 0.35% MSE, 5.88% RMSE, and 13.43% MAPE. This shows lower error values and improved accuracy and stability, which is suitable for reliable Bitcoin price prediction. Introduction. Bitcoin operates on a decentralized network and its price fluctuates rapidly due to various factors like demand, investor behavior, and global events. Traditional models like ARIMA cannot handle its nonlinear and irregular patterns. So, machine learning and deep learning models perform better, but single models fail during extreme volatility. So, hybrid models are used to combine strengths and improve prediction accuracy and stability. The performance of various machine learning, deep learning, and hybrid models are evaluated to develop a reliable forecasting system that will support better decision making. About the project. So, here the project aims to develop a hybrid machine learning and deep learning model to predict Bitcoin prices accurately. We use features like OHLC, volume, difficulty, and hash rate, along with technical indicators. Data is pre processed and enhanced using augmentation and feature engineering. Multiple models are trained and combined to improve accuracy and support better financial decision making. Problem statement. So, as we know, Bitcoin prices are highly unstable and affected by many unpredictable factors. Traditional models cannot capture sudden changes and complex time based patterns. So, the challenge is to design a system that can learn from large data and give stable predictions even during highly volatility. Problem specification. So, Bitcoin data is noisy, volatile, and time dependent, which makes prediction way more difficult. The model must learn non-linear and temporal patterns using advanced machine learning and deep learning techniques. The goal is to achieve high accuracy and stable predictions while handling real world challenges. Objectives of the project. So, the main objectives are to analyze Bitcoin data using features like OHLC and blockchain metrics to compare different machine learning and deep learning models, and also to develop a hybrid model that improves accuracy and reduce errors. And lastly, and to build a reliable system for better financial decision making. Scope of the project. So, this project basically focuses on Bitcoin price prediction using historical data and hybrid models. It includes data preprocessing, feature engineering, data augmentation, and model evaluation. It does not cover trading strategies or other cryptocurrencies. Applications of this project. So, this project can be useful for investors, traders, and financial institutions, also for fintech applications. It can also be used in automated trading systems, portfolio management, and research purposes. In market analysis as well, where it will assist studying price patterns and understanding market behavior. So, coming to the literature survey. As we've seen the first paper, they've used hybrid CNN plus LSTM model, which gave a R square of 0.99. So the limitation of this was they may struggle with extreme market events, computational cost. The second paper, which is written by Arsalan, here what they've done basically is they've taken two network hybrid model, which is EMD plus LSTM for historical price components. Here the sentiment based LSTM using positive and negative tweets emotions. Here their limitations was they were majorly dependent on tweet quality. Sentiment may be biased or manipulated. Heavy pre-processing required. Next paper, which is written by Zhang, Kim and Lee. The authors are there. Here, the applied algorithm is time series prediction using BiLSTM, and they've also included gradient importance plus ablation testing to identify key features. Here, the limitations are they've depended, like it was completely dependent on quality and availability of multiple external data sources, and also complex feature integration increases. Then the next paper was written. Here, the methodology was they've used five LSTM based models. They've tested them, and the best model was multi LSTM. Here, the limitation of them was they were completely relying on social media quality and noise. Sentiment data may be biased or manipulated. Coming to the fifth paper, here the methodology was like they've used LSTM plus attention, then LSTM attention plus gradient based optimization. Here the limitations of them was the performance was dependent on high frequency data quality. Computational cost is high due to attention plus hybrid model. So the sixth paper, here they've used four DL models, which were LSTM, LSTM GRU, by LSTM FB Profit. So they've compared it with silver kite. Also, variation point detection was used for stable forecasting. The limitation was the model depended on long historical data, which may not adapt instantly to market stocks. Then coming to the seventh paper, where they've used machine learning based classification using BERT GPT Glove embeddings cascade classifier. The limitations was only short-term predictions were considered. Also, accuracy depended on quality and timelessness of news data. Coming to the eighth paper, the methodology used was two attention-based models were used that were attention LSTM and attention GRU. Trend classification was done. Also, they've used technical indicators. The limitation of this was it only focuses on technical indicators, no sentiment or external factors if was included. Trend classification also may simplify complex market behavior. Then the ninth paper, here they've used deep learning classifications plus PCA for dimensionality reduction. They've compared against GLM, random forest, and decision trees. The limitation was it was highly dependent on quality of blockchain label data. And then the last paper, which we've taken in this, they've used two RNN models that were LSTM and GRU. Two-layer GRU with ADAM optimization was used, and then normalized time series data. The limitations was historical price data was used, sentimental or volume features weren't used. It was limited to three cryptocurrencies. Coming to research gap, What we've seen and studied was many existing studies use MLDL and hybrid models for Bitcoin price prediction, but they still have limitations. Some models fail during sudden market crashes, while others depend heavily on noisy social media data. Some approaches are complex and not suitable for real time use. So, there is a need for a model that is accurate, stable, and efficient. This project aims to address these gaps using a hybrid approach. Proposed methodology. So, our approach uses a hybrid MLDL framework to capture both short term and long term patterns. It includes preprocessing, feature engineering, and model training. We also use optimization techniques to improve performance. Finally, ensemble methods like stacking and averaging are used to reduce errors and improve robustness. This is the system architecture where we have taken the raw data, we have done pre-processing of the data, next we have applied feature engineering, then ML models were applied, then the DL models were applied, then hybrid model was applied, then all the metrics of these models were evaluated and the final output was done. Dataset description. We used a financial time series data of Bitcoin's prices with daily observation. It included hourly values. The target is the next day closing price. Features include OHLC values, volume, and technical indicators. The data is sequential, highly autocorrelated, and non stationary, which makes prediction more challenging. This is few sample of the data set which contains like values of OHLC volume, SMA 20, EMA 12, and so on. This is the year-wise plot of the whole data set which we've taken from 2014 to 2026. Data pre-processing. The data is cleaned by handling missing values, removing duplicates, and sorting it in time order. We resample data from hourly to daily to reduce noise. Scaling techniques like min-max and standardization are applied to improve model training. Train test list. We use a time away sliding window approach instead of random splitting. This maintains sequence order and avoids data leakage. 80% of earlier data is used for training and 20% recent data is used for testing. Data augmentation. To improve models' robustness, we applied augmentation techniques like noise addition, time shifting, and window slicing. These methods increase data diversity and help the model handle real world variety. As we can see, the original size was 2398 and the augmented size was 7194. Feature engineering. We extracted meaningful features such as price based features, technical indicators, momentum indicators, and time based features. These help capture trends, volatility, and temporal patterns. Non values generated during feature creation are removed to ensure stable training. This is the final feature data set, which had shape 2376,43. Implementation. The system is implemented using Python libraries like Pandas, Skitlearn, and TensorFlow. We trained multiple models, including ML models like linear regression, ridge regression, XGBoost, and machine learning models. Also, deep learning models like LSTM, GRU, CNN, LSTM. Hybrid models are also developed to compare performance, and the models were GRU plus residual, PyLSTM plus Ridge, proposed by LSTM plus Ridge. Hybrid model and evaluation. So, the hybrid model combines both ML and DL outputs using stacking and ensemble averaging. The proposed by LSTM plus rich model captures both temporal dependencies and linear relationships. Performance is evaluated using MAE, RMSC, and R square, along with validation techniques to ensure stability. These are the evaluation metrics where MA mean absolute error, squared error, root mean squared error, mean absolute percentage error, and coefficient of determination were evaluated. So this is the code. Here the data set was loaded and it was loaded successfully. VIF print the overall time series data. Then data pre-processing was done. All the techniques were applied. Duplicate time snaps. Then date by time resampling. Min-max scaling. Standardization. So this is the final data. Train test split was done here, where the final was this. Then data augmentation was performed. All the methods were applied. This was the combined augmented data. Then feature engineering was performed. We extracted meaningful features. Here, this is the final feature rich data set. The ML models were applied, the X and Y values were prepared, then common metrics function was applied, linear regression, ridge regression, lasso regression, XGBoost. Then all the results were compared together. Deep learning models, where we've prepared the sequential data. Then the common metrics function, GRU model was applied, CNN-LSTM was applied, then BiLSTM. These are the combined values. Now coming to hybrid MLDL models, BiLSTM plus Reg, then GRU plus Reg, then residual plus BiLSTM. All the models were compared. So this is basically the bar graph of all the hybrid models, the values which they've achieved. Then this is the model comparison of R square. This is comparison of RMSE. This is the actual versus predicted data. This is the residual over time. This is residual distribution, and this is the actual versus predicted scatter plot. So here comes the model comparison table. All the values have been combined together, and we can see the BiLSTM plus RIS have achieved the higher accuracy, which is 98.96%. Higher R square, which is 98.96%. Then RMSE 5.88%, MSE 0.35%, MAE 3.64%, MAP 13.44%. These are the graphs. This is of R square, and we can see for the hybrid model it is the highest. This is of MAP, and this is combined, which is of RMSC, MSC, and MAE. And we can see by LSTM plus it has the lower compared to the other ones. This is the actual versus predicted. We can see there's not much difference, so we can say that the model have actually predicted values accurately. Result analysis. So, the results shows that the proposed BiLSTM plus Ridge model achieved the highest accuracy with an R square of about 95.95%. Hybrid models performed better than individual models. This shows that combining deep learning with regression improves prediction and performance. Conclusion. So, in conclusion, the hybrid model, which is BiLSTM plus Ridge, successfully improves Bitcoin price prediction by capturing both short term and long term patterns. It achieves higher accuracy, lower rate, and stable performance even during volatile conditions. This makes it a reliable solution for financial decision making. These are the references. So, I would like to thank my guide for the valuable support and guidance throughout this project. Also, my supervisor and the HOD for their support. Thank you.